Guys, so in the warm-ups, I asked you to come up with a chart for y equals tangent x. All right, so we are going to be thinking about the unit circle in order to come up with these values. The values I asked you to check were negative pi over 2, negative pi over 4, 0, pi over 4, and pi over 2. Remember that x and y can represent anything. Yep. But in this case, thank you. So x and y can represent anything, but in this case right here, x is going to represent an angle and y is going to represent the output when we put in that angle. So when we're looking at this, these are the angles I asked you to check for. So negative pi over 2 is going to mean that instead of going up 90 degrees, we're actually going to go down 90 degrees. So we would be right here. And this point is going to be 0, negative 1. Now, you have to remember your tangent ratio. So our tangent ratio, if I'm trying to find the tangent of an angle, it's always going to be equal to y over x. We can also think of it as the sine of the angle over the cosine of the angle. In the unit circle, the y value is the same thing as the sine value. And the x value in the unit circle is the same thing as the cosine value. I think it's easier to think of it this way when I'm trying to do tangent. So I'm going to go to my angle measure of negative pi over 2, and I'm trying to do y over x. So what is that going to be right there? It's negative 1 divided by what? Which is going to be what? Undefined. Okay? At negative pi over 4, instead of going this way, we're going this way. The point right there is going to be radical 2, comma, negative radical 2 over, radical 2 over 2, and negative radical 2 over 2. So if that's our point, we're going to have to do y divided by x. And what is anything divided by itself but one's negative and one's positive? Negative 1. Okay, next we're going to go to 0. What's the point at 0? So what would y divided by x be? 0 divided by 1 is 0. Pi over 4, is this point's going to be radical 2 over 2, radical 2 over 2. So if we do y over x, what is it? And then at pi over 2, this is going to be the point over 0 up 1. So this would be 1 divided by 0, and what's that going to be? Undefined. Now, in the warm-ups, I told you that anytime you get an answer that's undefined, that means we're going to have a vertical asymptote. So here's negative pi over 4, here's negative pi over 2, here's 0, here's pi over 4, and here's pi over 2. So we're just creating an x, y axis with x being labeled in radians and y being just labeled in units, 1, 2, 3, etc. All right, so at negative pi over 2 then, we're going to have this vertical asymptote. And at positive pi over 2, we're going to have this vertical asymptote. That's not really part of our graph. It's just helping us to understand the way the graph's going to look. At negative pi over 4, what is our answer for the tangent of negative pi over 4? Negative 1. So I'm going to put negative 1 there. At 0, I'm going to have the point 0. And at pi over 4, I'm going to have the value of 1. Now, you almost would think this would just be a straight diagonal line, but it's not. Because what happens is, as we get closer and closer to a vertical asymptote, our function is just going to keep going that way. This is a divider. We're never going to cross it. Then we're going to come up this way. We're going to hit this point, and we're going to do the same thing, and we're going to approach that vertical asymptote. That's going to be one period of the tangent function. So where do you think the next vertical asymptote would be if I were to go on further in the x direction? Good job. 3 pi over 2. So down here at 3 pi over 2, I would also have this vertical asymptote. But just like the sine and cosine curves, we would continue the same pattern. What's the point in the direct middle of the asymptotes? What's the value right there? 0. So in the middle of these two, I would have a 0. In the middle of these two, what would I have? -1. And in the middle of these two, +1. So that would represent 2 periods of the tangent curve. Let's look at this on our graphing calculator. Let's go to y equals. And let's type in tan x. Not tan, just tan x. All right, so we've got that in there. I'm now going to check my mode, make sure I'm in radians. I am. What's the one I do if I want to make sure my window is set up correctly? Is zoom what? Zoom trig, because we want to have a trig function. And here's the way it looks. Now, on my graph, I'm only going from -pi/2 to 3 pi/2. So watch, guys, I can change my window. I can make this match up exactly. I'm going to make my window go from -pi/2 to 3 pi/2. And mine is increasing by pi/4. That's my x scale. Now I'm going to hit graph again. And now I should just see 2 periods of the tangent curve. Does that make sense to everybody? All right, let's talk about some important things here. If you know the vertical asymptotes, you're going to be in good shape for this. Also, guys, is this tangent curve increasing or decreasing? Increasing. So we need to know that y equals tan x is going to be increasing. And we also need to know that the vertical asymptotes are going to occur at x equals pi/2k, where k is an odd integer. All right, let's talk about why I said that. So x is going to equal pi/2k, where k is an odd integer. Because if I say my first one is at 1 pi/2, is that true? 1 pi/2 is a vertical asymptote? Isn't pi/2 a vertical asymptote? Yes. If I use 2 for k, what would 2 pi/2 end up being? Just pi. Is pi a vertical asymptote? No, that's a 0, right? Where's the next vertical asymptote? 3 pi/2. Where's the next one? Come on, guys. 5 pi/2. Where's the next one? 7 pi/2. Okay. If we go backwards, -pi/2, then where? Good, good, good. Okay. So this is the important information here when we have to graph tangents on our own. That's important to know. Why did I put a k there? Because I was thinking ahead. Increasing. So y equals tangent x is always going to be increasing as we go from left to right. And our vertical asymptote is going to be x equals pi/2k, where k is an odd integer. All right, now we're going to look at cotangent. Guys, I actually want you to put cotangent into your calculator. Do we have a cotangent button? So what am I going to have to put in instead? Y equals, not inverse, 1 divided by. I have to use the reciprocal of tangent. I'm going to do my zoom 7. Okay, and here's the way cotangent looks. You can probably just look at this and see where that first vertical asymptote happens. What's that going to be? What's the equation of that? X equals 0. Very good. So to get a feel for cotangent, I'm going to make another XY chart. But now we know the first vertical asymptote is going to happen at 0. And then we're going to use pi/4, pi/2, 3 pi/4, and pi. Notice that we're using different x's for tangent and cotangent than we did for sine and cosine. All right, let's go back to this unit circle now. I'm going to get a couple other points. So when I'm here at an angle of 0, cotangent, guys, you have to remember that cotangent is x over y, or you can think of it as cosine over sine. One of those two ways. Cotangent is x over y or cosine over sine. So when I'm looking here at an angle of 0 degrees, what is the cotangent going to be if it's x over y? Undefined, good. What about at pi over 4? If I do x divided by y, what's that going to be? 1. What about here at pi over 2, x over y? 0. 3 pi over 4, what's the point here? Nope, negative radical 2 over 2 and radical 2 over 2 at 3 pi over 4 first. So if we do x over y, what's that going to give us? Negative 1. Oh, you guys were telling me the answer. Okay, great. And then at pi, what's this point going to be? Negative 1, 0. If we do x over y, what's it going to be? Undefined. So if I'm not using the graphing calculator, then I have my vertical asymptote here at x equals 0. I've got pi over 4. Here's pi over 2. 3 pi over 4. Here's going to be pi for mine. Okay, so at pi over 4, right here, I'm going to be at 1 on the y-axis. At pi over 2, I'm going to be at 0. At 3 pi over 4, I'm going to be at negative 1. Okay, so this one, when I connect the dots, always approach those vertical asymptotes, it's going to look like this. So what's the difference, guys? Y equals cotangent x is always going to be what from left to right? Decreasing. I think of it as down because O has the O, cotangent has the O, so I always think cotangent's down, goes down. So then I know that tangent is the opposite. It's going to go upward from left to right. See how tangent's going to go up, but cotangent, as I go from left to right, is going to go down. Okay? That's just how I can look at a graph and tell whether it's tangent or cotangent. So, guys, if I just gave you one and it's going up, what does it have to be? Tangent. And if it's going down, it's cotangent. Okay, vertical asymptotes on this. What do you guys think? X equals 0 is 1, but where's the next one? Pi. So I could do pi times k, where k, does k have to be an odd integer this time? Where are the asymptotes going to be? 0, pi, where's the next one? 2 pi, 3 pi, 4 pi. So where k is what? An integer, any integer. Integers can be positive or negative. So this is the important information for cotangent. Okay, for both of these, what is the period for both of these? How long before they start repeating themselves? Pi, good. So the period is normally pi, but then we're going to have to take into account any horizontal stretches or shrinks, right? So if I want a formula for period for only these two, it's going to be pi divided by b. Okay, that's a formula you can use. What was it for sine and cosine? Not pi over b, but 2 pi over b, right? All right, let's look at some problems now. Make a table of values, graph one period for each function. State the equations of the asymptote. Note the period is going to be pi divided by the absolute value of b for tangent and cotangent. All right, let's make our chart. For tangent, our 5 key points are going to go negative pi over 2, pi over 4 negative, 0, positive pi over 4, and pi over 2. What happens at negative pi over 2? We have a what? Vertical asymptote. Remember, these points go like negative or positive 1 here. So in that fourth quadrant, is tangent positive or negative? So it's going to be negative 1 here. Then this point's 0, this point's 1. Here we have another vertical asymptote normally. Now, what does this 2x do? It's going to be a horizontal what? Shrink. So I now have to take my x's and multiply them by what? Not 2, but 1/2. Good job. So now I'm going to have negative pi over 4, negative pi over 8, 0, pi over 8, and pi over 4. Oh, yes, pi over 4. Okay, what is this 1/3 right here going to do? It's going to multiply our y's by 1/3, right? So this is a vertical asymptote times 1/3 doesn't change anything. But this is now going to be negative 1/3. That's still 0, and that's going to be 1/3. All right, all we have to do is graph one period. So I'm going to make this represent negative pi over 4. I'm going to make this represent positive pi over 4. I'm actually going to make this, well, okay, we'll make it standard. This is negative 1, positive 1. We'll just keep that the same as always. Okay, so at negative pi over 8, I'm going to be at negative 1/3. Then I'm going to be at 0, and then at positive 1/3. And so it's going to look like that. I just want to show you something on the calculator to check. We just use it to check, not to really do the problem. I want you would have to change your table setup and make your table start at negative pi divided by 4. And it would have to go up. How much am I adding up on here, guys, to go up every time? What am I going up by? Pi over 8. So I'm just checking my key points here to make sure they're right. So I'm going to go to my table. What do you think the error represents? A what? Vertical asymptote. Negative 1/3, 0, 1/3, vertical asymptote. Makes sense? What's this right here? 7e to the negative 14. 0. It's 7 times 10 to the negative 14, which is 0. Okay, guys, cotangent now. And guys, here's two. This is, I always think of tangent. That's the one that has the weird starts at negative pi over 2 and pi over 2. The first vertical asymptote for this one, though, is at what? You see the pattern there? Where's the first vertical asymptote here? Oh, 0, right? Makes it easier to memorize. O, 0. The O means 0. And what else does the O tell us? Down. So we have that first vertical asymptote at 0, and we know it's going to go down, whereas tangent went up, right? Okay, so our key points on this, we're going to check 0, pi over 4, pi over 2, 3 pi over 4, and pi. Now, the reason I separate them out like that, guys, is because the period is pi, and I'd like to have 5 key points, just like we did with sine and cosine. So if I'm only going from 0 to pi and I have to have 5 points, I'm dividing them up evenly. You see what I'm saying? All right. So for cotangent, what happens at 0 normally? We usually get a what? Vertical asymptote. What's pi over 4 going to be? 1, pi over 2, 3 pi over 4, pi. Vertical asymptote. Okay, let's check it out now. We have a pi in front of our x. So what am I going to have to multiply my x's by? Not pi, but 1 over pi, right? Can you guys do that for me quickly? 0. What's the next one going to be? 1/4. Next one? 2, I heard, not 2, but 1/2. Next one? Yeah, you should see a pattern. Once you get going, guys, you should see a pattern develop. Okay, so the y's are going to have to get multiplied by -2. That's not going to change these. They're still going to be vertical asymptotes. But what are these going to be now? This is going to be what? -2. This is still 0, and this is going to be what? 2. All right, let's make a XY axis. Okay, I'm going to make, this is still 0, but I'm going to make that 1/4, 1/2, 3/4. I'm going to make that my 1. Just makes it easier to graph. It's really hard to get all those in right there, you know what I mean? So that, my y's, I'm just going to keep normal. That'll be fine. Okay, so at x equals 0, vertical asymptote. X equals 1, vertical asymptote. At 1/4, I'm going to be at -2. At 1/2, I'm going to be at 0. And at 3/4, I'm going to be at 2. Connect those dots and graph 1 period. Now, I thought we said that cotangent goes down. What's going on? The negative reflected it over the x-axis, right? So that's why it's no longer going down. But normally it would have. Okay? All right. Very good. Let's do one now where we're given a function and we have to apply transformations. We have to come up with a new function. All right, so here's our original. F of x is equal to cotangent of 2x. Actually, before I do this problem, let me go back here real quick. I want you to see how we can check this chart quickly too. The period is supposed to always be pi divided by b. What's the b value in this case? 2. So if I do pi divided by 2, that's what the period should be. Is the distance from here to here 1/2 of a pi? Yes, it is. And that is as well. Okay, over here, the period has to be pi divided by b. What's b in this case? Pi divided by pi is 1. Is our period 1? Okay, just something else, another way you can check your graph. Because this would be on like a non-graphing calculator part. We're just using the graphing calculator to check as we go. All right, here we go. Write a rule for G that represents a translation 3 units up. So let's do that first. So our first change, we'll call this f of x sub 1, is going to be what? Cotangent of 2x, then what? Plus 3. Does the plus 3 need to be in parentheses? No. Okay, so we took care of that. We want to go pi over 2 units left. So this is going to be our second change. We'll call it f of x sub 2. What are we going to do? All right, good job. So we're going to do cotangent of 2, and then for the x, we have to put it in parentheses because we're replacing this x. It must go in parentheses as x, and then what is it, plus or minus? Plus. It's always the opposite with the x's. Okay, so we took care of that. And then a horizontal stretch by a factor of 1/4. Ooh, this is a tough one. What do I do on that? Replace the x with a what? 4x. So my final thing is I'm going to have cotangent of 2. This x right here has to get replaced with a 4x plus pi over 2. Plus 3. Oh, thank you. Now, let's get into something else that's interesting. If you are taking honors pre-calc, they would not want you to leave it like this because we typically like to just have an x inside of this parenthesis rather than a coefficient. Can you think about what would happen if I took this 4 out? I would now have an 8x. So I divided this term by 4. What would I get if I divided this term by 4? Pi over 8. This would be equivalent, and this is more simplified. Okay? I know, so really what I did when I took out this 4, guys, I took out a 4, so that became an 8. And I really did this times 1/4, which gave me 1x. And so I had to do this times 1/4. And watch how if I multiply it out, it should be the same. 8x, 8x. What does this become if I multiply it out? Pi. Does this become pi if I multiply it out? That's how I can check it and make sure we're correct. Okay, these are equivalent. We're just writing it in a different form. All right, so let me just quiz you real quick. Where's the first vertical asymptote for cotangent? 0. Where is it for tangent? Negative pi over 2. Good. What about tangent? Does it increase or decrease? Increase. Cotangent. Decrease. How do we find the period for both of these? Pi over b. Yep. And then what do we do for sine and cosine to find the period? 2 pi over b. All right, guys, great job. We are finished with that. Make sure you do